Welcome to Ask and Learn.
Hello. So to prove this theorem, we're going to let a sub n, b sub n, and c sub n be sequences of real numbers. Now, if we have that a sub n is less than b sub n, which is less than c sub n, and this holds for all n beyond some index. So after, right, beyond some index capital N, then we suppose that the limit as n approaches infinity of a sub n is equal to the limit as n approaches infinity of c sub n, which is equal to L. Then we let epsilon be a positive number. Then for all epsilon, there exists some n1 where we have that n is greater than n1, and we have that the absolute value of a sub n minus L is going to be less than epsilon, which then implies that negative epsilon is less than a sub n minus L, which is less than epsilon, which then implies that L minus epsilon is going to be less than a sub n. And we have that then there exists another n2 where we have n is greater than n2 and the absolute value of c sub n minus L is less than epsilon, which then gives us that same thing, negative epsilon less than c sub n minus L less than epsilon, which implies that c sub n is less than L plus epsilon. Now, if we have that n is greater than the maximum of n1 and n2, then we have that L minus epsilon is going to be less than a sub n, which is going to be less than or equal to b sub n, which is going to be less than or equal to c sub n, which is going to be less than L plus epsilon, which implies that the absolute value of b sub n minus L is going to be less than epsilon, which gives us that the limit as n approaches infinity of b sub n is equal to L.